Here we have the integral of e to the 2x sine x dx. Seeing the product of a couple of functions of x, I think integration by parts, but we kind of had a general rule of thumb that a good thing to call u would be the function that goes to 0 if we differentiate that enough times. And that's not going to happen here with either of these functions. Derivatives of e to the 2x are going to be multiples of e to the 2x, and derivatives of sine x are going to be cosines or sines, positives or negatives. So neither one of those is going to go to 0. However, integration by parts is still going to work with one little added trick. So let's see how to do this. I'm going to call this first part u and the second piece dv. So we have u equals e to the 2x, which means du is 2e to the 2x dx, and dv is sine x dx, so v negative cosine x. Now applying the integration by parts formula, that equals uv, so that's going to be negative e to the 2x cosine x minus the integral of v du, so that's going to be negative 2e to the 2x cosine x dx. We're going to apply integration by parts one more time. Well, first of all, I'll make this a positive combining those. Then I'm going to call this u and this dv. I'm going to actually put that down here at the bottom. Our u is going to be 2e to the 2x, which means our du is going to be 4e to the 2x dx. And our dv is cosine x dx, which means v sine x. Now I still have this first piece, negative e to the 2x cosine x, and applying the integration by parts formula plus uv, so that's going to be 2e to the 2x sine x minus the integral of v du, so that's going to be 4e to the 2x dx here. Now we can see if we keep applying integration by parts that it's going to just keep alternating, but this integral that we just got here is the same type of an integral as this one. If I move the 4 out in front here, I could move this whole thing over to the other side. Now remember, this is what we started with and this is what it equals. So if I move this negative 4 integral of e to the 2x sine x to the other side and combine it with the one that's already there, I will have 5 times the integral of e to the 2x sine x dx. And then on the other side I have this negative e to the 2x cosine x plus 2e to the 2x sine x. What's going to happen now is I am going to solve this for this integral. So I am going to divide by 5, which would be essentially multiply this side by 1/5, and I will have then a formula for the integral of e to the 2x sine x dx, and it will equal this side, and then we would need our constant of integration. So let's go ahead and write that. The integral of e to the 2x sine x dx equals, I'm going to go ahead and factor out this e to the 2x out with the 1/5. So it's going to be 1/5 e to the 2x multiplied by negative cosine x plus 2 sine x plus a constant.